Here I have a problem from the AIME 2004 math contest. And it tells us that we have a bag of 20 candies, 10 of which are blue and 10 of which are red. And if I pick 2 and you pick 2, what's the probability that we end up with the same combination of candies? In other words, if I pick 2 reds, what's the combination that you pick 2 reds? If I pick 2 blues, what's the probability you pick 2 blues? And if I pick 1 red and 1 blue, what's the probability that you end up with 1 red and 1 blue? So let's get into it. I'm going to separate it into 3 different cases, the ones I just outlined to you. So in case number 1, I pick 2 reds. So because there are 10 of each color candy, there is a 1/2 probability that I pick a red with my first selection. And then for me to pick a red with my second selection, there's no replacement here, which means there's 9 reds left and 10 blues left, which means the probability of me picking another red at random is 9/19. But then you also have to pick 2 reds. So that leaves us with 8/18 reds left, because there are still 10 blues, but 8 reds left. But simplifying that down, we can find that that's 4/9. But now the probability that your selection is also red is 7/17, because we've picked 3 reds here, leaving us with 7 reds remaining. And we also have these 10 blues for a total of 17. So 7/17 here. And we'll multiply and add all of our combinations up at the end. So that's case number 1, where we both pick 2 reds. Now let's look at the case where we both pick 2 blues. So again, we have a 1/2 probability that I pick a blue off the start, and then a 9/19 probability that I pick a blue with my second selection. For similar reasons, we'll have 9 blues left and 10 reds left. And this is actually going to mirror the red probability exactly, because there is an 8/18 probability that you pick a blue with your first selection, because there's 8 blues left, but 18 total, and then a 7/17 probability that you pick a blue with your final selection, because there's 7 blues left and 10 reds left. So this probability is when we are both picking blues. So in both of these cases, we can cancel our 9s here in the top and the bottom, and that'll leave us with 28/646, and that goes for both of these cases. And now we'll move on to the case where I pick one of each color candy and you pick one of each color candy. So first, I have a 1/2 probability of picking either candy in the bucket. And then after that, I have a 10/19 probability of picking the other candy in the bag. But now we'll multiply this by 2, because in one case, I'll be picking out a red, and in the other case, I'll be picking out a blue first. So that's why we want to multiply this by 2. And now we need to calculate the probability that you pick one of each color as well. So if I pick a red first and then a blue second, the probability that you pick either color is 1/2, because that's 9/18. And I've picked one of each color, leaving us with 9 remaining for each color. But then after that, there's a probability that you pick the other color of 9/17. But again, because we're working with 2 different combinations here, one where I pick a red first and then a blue first, and then one where you pick a red first and then a blue first, we want to multiply this by 2 as well. So we can simplify this down by canceling these 2's here and just getting 90/323. But now we are ready to find our total. So we have 28/646 here, 28/646 here, and 90/323 here. So we'll have 14 plus 14 plus 90/323. That's just by factoring a 2 out of each of these, leaving us with 323 in the denominator here and 14 in the top. But then adding all of that together, we get 118/323, which is the probability that we select the exact same combination of candies. And that's enough for now.